In this lesson, we're going to be solving equations graphically, numerically, and algebraically. The graph of the equation y equals 2x minus 5 in x and y can be used to solve the equation 2x minus 5 equals 0 in x. Using the techniques from section P.3, we can show algebraically that x equals 5 over 2 is a solution of 2x minus 5 equals 0. Therefore, the ordered pair 5 halves 0 is a solution of y equals 2x minus 5. The figure at the right suggests that the x-intercept of the graph of the line 2x minus 5 is the point 5 halves 0 as it should be. So what that tells you is the solution of the equation 5 over 2 is the same as the x-intercept. Now, one way to solve an equation graph is to find all of its x-intercepts. There are many graphical techniques that can be used to find x-intercepts. Now, example 1 here says solve the equation graphically by finding x-intercepts. Confirm algebraically. So what we're going to do in our equation here, we're going to put in 2x squared minus 3x minus 2. So once you do that, 2x squared minus 3x minus 2, you're going to press the graph button. All of your calculators should have the forms negative 10 to 10, negative 10 to 10 for your window. So this is your standard window. To get to your standard window very quickly, you press zoom 6. That will get you to your standard window. Now, as you can see, this is a parabola. This is a quadratic equation. It's got a power of 2 with the x. So we know it's going to have a possibility of 2 real answers. As you can see, that's what we have. Now, to find your zeros, you press the second button and trace. Go down to 2, which is 0. Now, we want to go to the left of our 0. We want to go to the right of our 0. Now, you should, after you do that, the first 2, you should see 2 arrows pop up near the top. Press enter on guess. There's our first 0 at negative 0.5. To find our second 0, again, go through the same process. So there's our second 0 at 2. Now, to confirm this algebraically, we're going to have to factor. Now, the method I always teach my students is this. If we take 2 times negative 2, you get negative 4. Are there 2 factors, 2 numbers that multiply to get negative 4 that also add up to negative 3? Well, you should be thinking to yourself, well, yeah, negative 4 and positive 1. Well, my only 2 options for 2x squared are 2x and x. My only 2 options for 2 are 2 and 1. Well, the only way you're going to get 4 is if you multiply 2 times 2. So the 2 will go there, the 1 will go here. We need a negative 3 in the middle, so that should be a negative there and a positive there, and it does equal 0. Now we're going to use something called the zero factor property. Set them both equal to 0, which you all should be comfortable with. Subtract 1 divided by 2 means x equal negative 1/2. Add 2 here, x equal 2. You just confirmed algebraically that those are your zeros. We'll do much the same thing in letter B. Plug these in. As you can see, we have 2 zeros again. There's my first 0 at negative 4, 0. There's my first 0. My second 0, again, we're going to use your arrow keys. And there's your second 0 at 5. Now we need to confirm it algebraically. Only two factors of x squared are x and x. Two factors of 20 are 5 and 4. That will give you the 1. We need a negative 5 and a positive 4, which means x minus 5 equals 0, x plus 4 equals 0, which tells you then that x will equal 5, x will equal negative 4, which does confirm our zeros. The algebraic solution procedure used in example 1 is a special case of the following important property, the zero factor property. Let a and b be real numbers. If a times b is equal to 0, then either a equals 0 or b equals 0 or both equal 0. In mathematics, we'll assume that both will equal 0. Now, solving quadratic equations. Linear equations, ax plus b equals 0, and quadratic equations are two members of the family of polynomial equations, which we'll study more in detail in Chapter 2. A quadratic equation in x is one that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a cannot equal 0, because if a did equal 0, you wouldn't have a quadratic equation. Now, we're going to review some of the basic techniques for solving quadratic equations. One algebraic technique that we have already used in example 1 is factoring. Quadratic equations of the form ax plus b quantity squared equals c are fairly easy to solve, as illustrated in example 2. Now, solve each equation algebraically. What we're going to do then, we're going to take the one thing that we need to remember here. We have 2x minus 1 quantity squared equals 9. So what we're going to do here, we're going to take the square root of both sides. So when you do that, you have the 2x minus 1 on this side, and then the square root of 9 is a positive and a negative 3, because negative 3 times negative 3 is positive 9, and 3 times 3 is positive 9. So really what we're going to have two separate equations. So when you solve this, we're going to add 1, and then divide by 2. So we'll have 2x equals 4, x will equal 2. And here we're going to add 1. So we have 2x equals negative 2. Negative 2 divided by 2 is negative 1. So here are our answers. Simple enough. Now we look at B. What we're going to have to do first, we're going to have to divide both sides by 3. That's what we're going to have. Then we can take the square root. Now we're going to have a square root of 8 over 3. So when you solve that, add or subtract 4, x equal negative 4 plus or minus the square root of 8 over 3. For right now, that would be an acceptable answer. Now, if you really want to go into it, we could figure out the numbers here, negative 4 plus the square root of 8 divided by 3. Then negative 4 minus the square root of 8 divided by 3. So we'll have the answers of negative 2.37 and about negative 5.63. So those are our answers right there. Now the technique of example 2 is more general than you might think, because every quadratic equation can be written in the form of x plus b quantity squared equals c. The procedure we need to accomplish this is called completing the square. You will be so good at completing the square this year that you won't want to use any other method. Now, to solve x squared plus bx equals c by completing the square, we're going to add b over 2 squared to both sides of the equation and factor the left side of the new equation. So the big thing is we want to take half the number in front of b, or in front of x, and square it and add that to both sides. Then when you factor it, this number will automatically come here. Simple enough. We'll go through some problems here. To solve a quadratic equation by completing the square, we simply divide both sides of the equation by the coefficient of x squared and then complete the square as illustrated in example 3. So what we're going to do here, we're going to complete the square. We're going to divide all these numbers by 4. So we'll end up with x squared minus 5x plus 17 over 4 equals 0. Now the method that we need to use here, we need to take 17 over 4, move it to the other side. So x squared minus 5x, I'm going to leave a space, equals negative 17 over 4. Now up above, it said take half the number in front of x. Well, half of 5, I know you want to say 2.5, well half of 5, we're going to leave it as 5 halves squared. Then we're going to add 5 halves squared to the other side. Now when we do this, remember the number that we take half of, that's going to come right down into the factoring part. So I'll end up with x minus 5 halves squared. And that's going to equal negative 17 over 4 plus 25 over 4. Well, negative 17 over 4 plus 25 over 4 is really 8 over 4, which is 2. So now when we solve this, well, x minus 5 halves squared equals 2. We're going to take the square root of both sides. That'll be plus or minus the square root of 2, which means x will equal 5 halves plus or minus the square root of 2. Now, if you are confused by this, don't worry. We'll be going through a lot more of these. Part B. We don't have to divide like we did in the original. We just work through. We're going to move this negative 9 to the other side. Half of 5 is 5 halves. We're going to factor, so x plus 5 halves squared is equal to 9 plus 25 over 4. You can do this one of two ways. You can say, well, 9 is really 36 divided by 4. (36 over 4 plus 25 over 4). That'll actually give us 61 over 4, which is fine right now. So really what we're going to have, we're at x plus 5 halves squared is equal to 61 over 4. Again, we're going to go through the same exact process. Take the square root of both sides. Now you should be able to see that we can extract a square root on the bottom. Square root of 4 is 2. So when we solve this then, x will equal a negative 5 halves plus or minus square root of 61 over 2. And there is your answer.